using FPG-eAG difference as a longitudinal indicator of diabetic retinopathy risk, number 1244, VMT Sharp 627, April 11, 2025, Gerald C. eclaireMD Foundation. Category, Diabetes Complications. Abstract, the value of FPG-eAG can serve as a quantitative and practical indicator of diabetic retinopathy, DR, risk, particularly when evaluated over an extended longitudinal period. This difference reflects glucose instability, a recognized contributor to microvascular complications, including DR. FPG, fasting plasma glucose, represents a short-term glucose level measured at a single point in time, typically early in the morning before breakfast. In contrast, EAG, estimated average glucose, reflects the average daily glucose level, derived from HbA1c. A large positive FPG-eAG gap indicates frequent glucose spikes and overall instability, whereas a small or negative gap suggests consistent and stable glucose control. Using the author's extensive self-collected glucose data and annualized summaries, spanning over 13 years, from 2012 to 2025, this study investigates how long-term glucose stability, as reflected by the FPG-eAG gap, correlates with the clinical progression and eventual reversal of the author's DR condition. According to Dr. Donna Lee, his ophthalmologist at Stanford Clinic, the author's diabetic retinopathy began improving steadily from early 2014 and was fully resolved by April 2024. This clinical recovery, although gradual, has been maintained for more than a decade without recurrence. The decline and stabilization in the FPG-eAG gap closely parallels this improvement in his DR clinic status, suggesting a strong association between glucose stabilization and retinal health. To further quantify this biomedical relationship, the author applied the viscoplastic energy model, VMT, to assess the internal stress and potential damage imposed by glucose fluctuations of both FPG and eAG on his retinal microcirculation. The calculated VMT energy contribution ratios from each factor are: FPG contribution, 52.41%, eAG contribution, 47.59%. This analysis suggests that fasting glucose, FPG, exerts a slightly greater impact on his retinal stress load, compared to long-term average glucose, EAG. While postprandial glucose variability remains clinically relevant, elevated, fasting glucose appears to be more influential in driving his long-term DR progression and risk.